And once again, everybody, welcome to the fifth in our series, Switching into Safety Engineering, sponsored by Oikna. And this time we'll be focusing on emerging safety technologies in the context of a lot of new technologies like Industry 4 that have been have come into the market since safety technology was first conceived. We have an excellent panel today. We have David Dearden, the UK and Ireland country manager from Oikna, who's been a regular attendee at all the previous seminars as well. And Paul Simons, who's the safety services manager from Oikna. But in addition, we have a new panelist today who is Oliver Selby, who is the robotics business development manager from Fanuc. And he's going to talk about the collaborative robots implications of safety, which will be a very interesting aspect. Now, a few years ago, safety systems were really simple, just a safety interlock switch of some form. But with all these new technologies and new demands, more human-machine interaction, safe speed, defect avoidance coming on stream, the need for high OEE or overall equipment effectiveness, surely none of this has really impacted the safety industry. And we're going to ask David in a moment just to either agree with that or counter that idea. While we're speaking, we invite you all to put your questions and comments into the chat, and we'll take as many questions and comments as possible, not so much towards the end of the event, but during it as far as possible, as and when topical things come up. So don't be shy, put your comments into the chat as you think of them, and we'll try to take them. So safety systems, still a very simple technology, David. Tell us if that's true.
Partly true, yeah, I would say it is partly true, but there is a lot of drivers that's affecting the way that we use safety technology on machinery. I mean, from the outset, I would like to say that thankfully the machines that I get involved with on a day-to-day basis are becoming safer. We're seeing a better standard of knowledge around the standards and around the regulations, thankfully. There is still a gap, and there's still a gap to fill there. And, you know, Paul spends quite a lot of time out there educating and working with customers to try and fill that gap. But I would say that the standards are going up. One big driver right now, Andy, is that people want to do a lot more with safety technology. So in the past, and we've all seen the advancements in technology from the manufacturing side, but in the past, the safety systems generally used to be open a door or hit an e-stop, the safety system shut down the entire machine, production stopped, you did what you needed to do, got it all up and running again. But of course, you know, first of all, the machines have got more complex. They do require more and more operator integration, and I know Oliver's going to talk a little bit about the Cobot side in a little bit with operator intervention. But because of that, of course, the safety systems have also got more complex, and we've seen, you know, systems that sit on field bus networks such as a ProfiSafe and SIP safety over Ethernet IP. So the involvement has happened or is happening, and the adoption, I think, is being driven by the needs of the end customers. You know, so if you're having a machine, a paper machine that needs a web feeding into it every 25 minutes, you're not necessarily going to want to shut that machine down for half an hour to do that if you possibly can. And so, yeah, we're definitely seeing a move towards more complex safety systems. So you know, the day where you had a safety relay in a control panel just being dropped out by a guard switch, they're still there for very simple machines. But I think, you know, over time, we're definitely seeing that move away.
Okay, thank you. How would that specifically relate to the collaborative robot environment, Oliver?
Yeah, I completely concur with David in his assessment there that things have gone really from a hardware-based software safety system to more of a software-based safety system. What we see within the robot hardware, the controller, certainly that we offer, is that customers are driving us to be more software focused. As we said, higher implementation of field bus type protocols to ensure we get the best out of the safety system. Now, in regards to collaborative, all our controllers have the ability for Profinet safe, Ethernet IP safety, or CRP over Ethernet. And what that does is allows us to also drive some of the process type variables that we see Cobots requiring. What I mean by that is that, for example, we can use a safety sensor to effectively drive the safe speed of a robot. As you approach a robot, for example, you can effectively slow the robot down using a floor scanner with its different zones, not necessarily stopping it completely. Like a mechanical guard may do, we can actually slow the robot down before you actually get to a point where it's actually completely unsafe and you do need to stop the robot. So we're actually driving the process through safety also. I think one of the things that we see also is that the hardware that certainly we provide with our robots is totally geared up for software-based safety systems, where we see the latest robot controllers coming with dedicated hardware and software control for floor scanners that we haven't seen in the past. This ability to work with, say, Cobots working without guards is driving the way in which the hardware and software is being put to the market through the different vendors.
I was going to ask. Sorry.
Go on, Paul.
No, it's just a curiosity thing, really. Is from a business point of view, what are you seeing? Are you seeing a recognised chain, sort of people changing from traditional industrial robots to collaborative robots, or is it still kind of a fringe thing that people are kind of testing out and not quite implementing into full production manufacturing?
I think the reality is that customers will come to us now asking for a Cobot. That's the first thing that maybe someone within their senior management team has kind of asked them to go and look at. Now, typically what happens is that they'll ask us to look at a Cobot solution where there's an application that's not actually safe. The Cobots themselves are inherently safe in their own right, but as soon as you put a tool on the end of them or ask them to do anything, that has to be risk assessed correctly to ensure that the complete application would be inherently safe in its own right. And in the majority of cases, it's not. So you have to look to alternative safety methods to actually make sure the whole complete application, the process, is safe. In majority of cases where people have bought a robot, a Cobot, an application, what we actually end up seeing is that the robot finally ends up behind a safety guard. And the reason for that is that the health and safety persons come along and say, well, that's not safe, I can't allow that. The easiest way to get around that is to put a guard around it, and then implement the guard safety into the robot's safety system. Around about 5% of the cases that we look at where people have asked for Cobots actually end up being a Cobot application, so not many at all. Yeah. And in the majority where people have bought a Cobot, they do end up going along with some sort of safety system to ensure they are safe in the process. If we're looking up front at these processes, in the majority of cases, we will either, or nearly always, direct the customer to look towards an industrial robot solution rather than a Cobot, because what they end up with is a cheaper robot, or a more cost-effective robot, with a standard industry standard control system, probably interlocks, guarding, safety floor scanners, that sort of thing, but with a slightly cheaper robot that will potentially even work quicker than a Cobot because of the way industrial robots are specified. And then they have quicker motors, they have quicker arms, because they can go behind a normal safety interlock guard solution.
I think,
presumably, I mean, if you were to put a cobot behind a machine guarding system, then you're defeating the whole point of a cobot in many cases.
Absolutely right.
So, and it's interesting that only 5% of the applications actually end up being cobots in the end. So why do people start by asking that? Is it simply because there's a lot of hype around the concept?
That's typically it, Andy. It's a buzzword. Yeah, people see quite a lot of social media via LinkedIn or other means to actually that point people to go and look at cobots as solutions. But what you'll notice is the majority of those social media posts are generally university-led projects with no safety, not real production type systems. And maybe the industry, as an industry, as a robotics OEM, we need to do more to educate people on what actual cobot applications do look like. Typically quite slow. If people saw the risk assessment and the UKCA or CE marking requirement we have on cobot systems, they'd be shocked. It's at least double the amount of paperwork to get a cobot solution through in a typical production system than an industrial solution.
And that's a really good point, Oliver, because we've seen even over LinkedIn a lot of posts where they're showing robots with no guarding in, and I think there is the hype, Andy, that people think they can just put a cobot on the shop floor and off they go. There are some consultants out there, and some very good consultants out there that can work around the whole cobot story. But when you start looking at the requirements that's needed from a cobot installation, it is quite onerous. And so for an end user just to buy one off the shelf and bob it on the shop floor thinking that everything's okay is quite far from the truth, quite honestly. There's a lot more work than he's doing.
Well, Matthew has made a comment in the chat, so we're into the chat quite early, but it's very relevant. He says that I think it depends on the cost of the cobot, so maybe that's something we could talk a little bit about. And I see people buying cobots from certain manufacturers, guarding them, and their belief is it still works out as cheaper than an industrial robot. Well, from what you've said, you'd counter that, wouldn't you?
I would absolutely.
So, Oliver, I was going to say that that it'd be worth you mentioning about the construction differences, because they are very different beasts, aren't they? And we've had a conversation about that. I think
absolutely. So I mean, the control system typically is very similar, but actually the mechanical makeup of a cobot versus a normal industrial robot is quite different, in that there are additional force and torque sensors within each axis that makes it typically a more expensive unit than an industrial unit. So, for example, a like-for-like unit with, say, a 10-kilogram payload from Fanuc, you'd be paying around about, say, 20,000 euros for a 10-kilo industrial robot versus maybe 27,000 euros, 28,000 euros for a cobot of that similar size. And what you get is an industrial unit that can work twice as quick. Yeah, it's got pretty much double the speed, same payload, same reach. So yeah, it's probably around about 20-30% different to buy a cobot over a normal industrial unit.
Right. They do have their place. Let's not diss cobots at all.
No, we mustn't do that.
They do have their place, and there are some super examples of where they are being used in.
Yeah, and we must.
Environment.
Just before we move on, a couple of questions as well that I've come up with is we hear a lot about chip problems with the automotive sector at the moment. Would that be something that's affecting robot manufacturers as well?
Yeah, unfortunately, yes. Well, certainly affecting us. Our deliveries are pushed out from our normal levels. So typically in the past, we've tried to aim to keep around about 2,000 robots in stock in Europe for the European market. Unfortunately, we're down to around about 20% of that level at the moment. Partly through global shipping crisis also, we can't get the robots over to Europe and to the US from our Japanese manufacturing plants. But also we are having some issues with certain main boards not being delivered because of some chips being required. Specifically around the vision systems, believe it or not, I think the high processing requirement for vision systems globally is causing issues with some chips. If you think about it, say even within the automotive, the technology now that's built into a car with vision systems for adaptive lane control and all-round vision and to make it help you park. This is all connected, you know. So it's unfortunately, yes, we are seeing issues.
Let's hope that gets resolved as quickly as possible. One question: you said that the systems are very software led, and my sort of question would be, well, but what does that mean? How much of the software is like general, and how much of it has to be customized, and what does that involve?
Okay, so from a software perspective, if we take, for example, an older style system with a safety relay as such, there wasn't much configuration there. It was kind of the wiring, the hardware was really the configuration. When we look at the software PLCs, safety PLCs that are available, we actually have to take some software by the PC and actually then configure that kind of relay switch to ensure we get the right delivered safety outputs from that system based on what inputs we receive. So we can actually start configuring the way in which the safety works for our benefit. I mean, David, I think, has got some tools within his toolbox there that he can talk about in regards having hardware that works alongside software to deliver a different result from what has been typically available in the past. Certainly when we look at things like, say, lockout systems and that sort of thing.
Yeah, yeah, absolutely, Oliver. You know, you take the traditional, you know, padlockable lockout, tag out type systems that people use. And Andy, this goes back right to the very beginning when you were saying, you know, has safety really changed? The perfect example, Oliver, thank you, is that, you know, we see plants, paper industry is one area where operators are going in maybe 30 times a shift to feed in a web, clean some rollers, whatever it might be. And their processes right now are lockout, tag out on that type of equipment, which is quite cumbersome. And there might only be areas where, you know, there's one or two operators going in, but by installing simple, very effective RFID type systems, I've got one here just to show, which is literally a key, which you could have a suite of these on a panel. You pull one out, put that in your pocket and walk into the machine. It's never going to restart, and you're not having the situation that you do have with the cumbersome lockout tag out, where in effect operators end up not doing it because it's a faff. So it not only improves OEE, but it actually improves the safety integrity as well, because people, you make a system that people will actually use.
So how do you work together as a pair? You know, do you get in at ground level with Fanuc at the machine design level, or at the implementation stage, or how would it work?
For us, Andy, sorry, was that a question to me?
Yes, and
yeah,
then
yeah.
I'm sure Oliver would like to comment.
Yeah, no, well, very briefly, yeah, absolutely. So we'll work with Fanuc and obviously others, but we work with Fanuc at that early adoption stage to look at the solution and actually see what are we trying to get out of the solution, not just let's throw technology at it. And I think that's really important. Even when you go back to the Cobots discussion, you know, the customer, the end user, the designer has to decide actually what is it that they want to do. Are they using a Cobot because it's trendy and that's what they think they should do and that's the way the market's going? Or are they actually wanting to move 300 packets of widgets every hour across a factory floor onto a pallet? And it's going back to those basics. And yeah, we'll do that with all our customers, Andy. But I'll let Oliver have a.
Yeah, absolutely. So I mean, we see a trend within businesses across not just the UK but Europe in the designers, as you say there, David, looking at safety. And the way in which safety can support the process very early on within the actual the concept generation for automation. The best sort of example of this is that we recently provided a project to a company in Ireland where the only way in which we could actually make the process work and have the production flow we needed was to actually implement a servo system that would not normally have a manual control, but we used the safety system to actually drive what should have been an automated solution into a semi-manual solution. Yeah, and the safety system we put in place for that was driven through safety, and that was conceived in the very early stages with a number of different vendors of the safety devices involved. So yeah, I mean, it's happening at a much earlier stage, this kind of safety discussions, than it ever has in the past, certainly.
I think it's an approach and a concept kind of thing. Is that the earlier you can engage with a customer or client about what they want to do and how they want to do it, and how flexible they are in adopting new technologies. Some customers, and as you know, and you'll probably experience it as we do, they've got one somewhere else in the factory and they just want an exact replica, even though that one's probably 20 years old and has got 20-year-old technology on it. But because they feel comfortable, they just want one of those. And if that's got a lockout, tag out system on it and old technology, they just want the same thing. Whereas, you know, through that discussion, there might be better ways, there might be more cost-effective ways of doing the project and application. So it's how open they are to that kind of change and how open they are to newer technologies. And I think that's an important part, and kind of what Ian in the comments has said as far as making people aware of industrial change and how do you go about that, and whether it's taught in universities where, you know, the next generation of engineers are already wanting to know about these newer technologies and they want to use these new applications, or whether it's something industry can do to try and educate the existing sort of engineering and portfolio of people within industry to say, well, these are the things that you can use to improve on what you have been doing.
I think it's a combination of the two, isn't it, really?
Yeah.
Because I know, you know, Oliver's mentioned this morning training courses. I know David and Oikner are very big in training courses as well of various types, which perhaps you might both want to sort of elaborate on what you do. But equally, we need to train the up and coming engineers. Although we don't have many of them, it seems we need a lot more. But you know, and that involves getting into the universities as individual lecturers or invited industrial lecturers, and also getting your equipment into universities, which I expect you probably do anyway. I know in a lot of technical areas, you know, people do almost give their equipment to universities for free, because when people become familiar with particular technology and then they go work for a company, they're very likely to specify the same type of equipment. So it's a whole combination of those things, isn't it? So what do you guys do about your training and informing universities?
Just before we get onto that point, Andy, I just noticed Matt White has put a comment in, and it's very relevant. So just want to talk about that. Matt's really talking, at what point do you think is optimal to really define the safety requirements? Now, if we go back to the old safety circuits, generally it was everything shuts everything down, so it wasn't considered. Now the safety design can have such an implication on the way that the machine operates, the amount of downtime that machine's got, and the throughput of the machine. And so it has to be considered, I think, right at the front end of the project, whereas before it used to be an afterthought. And I still would say that there are too many mechanical designers selecting the safe measures that are being put on equipment because they pick a product out of a catalogue and not speaking necessarily with the electrical and the control systems teams to actually see, right, what do we want to achieve here? And I'll give you a great example of that. Multifunction gate boxes are, in my opinion, the next big thing. They are a super technology where you integrate both the locking systems that are on the machines as well as the push button and operator interfaces. It just makes common sense. I was at a client's a couple of weeks ago. They made a control panel that had some push buttons on. They had to make a fabricated lock cover, a welded ring for keys, and a mechanical emergency escape type lock on the hardware that was proprietary for an architectural ironmongery type door lock. All of that could have been included in a multifunctional gate box, which is in effect a safety switch, door handle, and operator controls all in one. And the big benefit of those, of course, is that they sit on field bus systems. So you could have that on Profinet, 2 wires in, 2 wires out after the next one. And it's such a simple thing. And of course, you're not using IO points either, the fail-safe IO points and the control cabinet that's needed for that. And so not only do you get a more efficient and better solution, it actually, as far as the total cost is concerned, generally, and certainly more times than not, they are a lot cheaper as well than all the.
I completely agree, David. They are a lot cheaper. Typically, from our study here, we use those locking mechanisms on nearly every project, and it's around about 30% cost reduction by using a multifunction gate lock versus the old traditional way of having a key exchange system plus a separate constructed sort of push button station next to the door to release and stop the robots and restart the robots. So you're absolutely right. It's probably around about 30% reduction by using multifunction gate lock. So.
And I can promise you, I didn't prompt that question with Oliver at all, honestly. So yeah. And yet I still talk to customers, show them a solution of the MGB unit, the multifunctional gate box unit, and we've had them out for over 10 years. They are a proprietary item, and customers look at them and go, yeah, well, I can buy a guard switch for this. Yours is a bit more expensive. Now I'll stick with the guard, and that's because the decisions are being made by people that aren't necessarily looking at the total picture. And I think that integration needs to come together in our design departments. We've talked about collaboration between IT and operational technology, but exactly the same between the mechanical and the electrical designs. And some companies do it very, very well, but there are still some companies out there that maybe could learn a thing or two from some others.
Yeah, to answer a couple of the questions there, at what stage do we look at the safety hardware within the system? So those gate locks, for example, will be designed in at a quotation stage, believe it or not. So even before we've actually got a design on the table, we will have costed and we will have designed into the proposal the safety system, and the safety schematic will be detailed within the proposal because it's so important to us. It normally helps us drive the discussion with the customer when we come to present those proposals. It also helps us validate the pricing to the customer. Yeah, we show them an example of what this gate is going to look like, what this door switch is going to look like. Yeah, the lockout mechanism. It's important because if they can touch and feel at the design stage, they're bought into the whole concept of what we're trying to offer. Yeah, it shouldn't be a second thought to them that the safety of a system or an automation system is paramount. Yeah. It needs to drive the conversation. I think there's a second question there about how cost effective, but I think we've probably covered there. In that the majority of hardware and software based tools are probably now on a par with the older style solutions in terms of cost, but you get so much more for your money. Yeah, the value add that they bring is a huge amount more. From preventative maintenance to ensuring that the ability to defeat the system is almost zero. Yeah, or it is zero. Yeah, it has to be, to ensure that we maintain the right safety standards.
There's a question
how would go on, Paul?
Go on, sorry.
Yeah.
I was just referencing Thomas, who was just saying there's a sort of a perceived benefit of cobots and how easy they are to reconfigure. So going along with what we're talking about as a general discussion about using technology and how flexible it has to be, are cobots, do they lend themselves to that repurposing more than industrial robots? Can they be sort of reused in different applications, i.e. reprogrammed to do different things?
The reality of that is that it comes down to the process. If you've got a robot that's working, for example, machine tending, yeah, and then the next application you want to use it for gluing, if there's a process change, it needs risk assessing. It needs to be maintained. It needs to be a CE mark or a UK CE mark maintained, whatever the process is. If the main purpose of that robot is changing or the environment, Yeah, so moving from one machine to another, it still needs risk assessing. But unless you're going to be able to look into the future and say, okay, my Cobot is going to work on this machine, this machine, this machine, and then so after 6 months, I'm going to reconfigure it. Unless you want that integrator who's delivering that machine to risk assess all those applications, yeah, and you pay for that service, then I think it's not a particularly good idea to try and reconfigure a robot. Yeah, you see pictures on social about